I love Solid. It's a decentralized web network that lets you store data anywhere, but lets you connect that data as if it were one database. Eventually, the goal is to link all knowledge together into one massive global database that developers can query to get any information about anything, both public and personal. That's amazing! But even I'll admit there's a lot to do before we get there. For example, to simply change your name in Solid's global database, this is how you do it today. The first step is to fetch a document containing your profile. That seems pretty straightforward. Now, in this case, fetch the document that we're extracting to extract it string the RDF subject node that will name it, just as we now and finally, we save the document and update the name. Yeah, this might make sense for someone who has experience with Solid, but if you ask most developers to log and change a profile name, they'd much rather do this than this. And if Solid is going to take off as a global database that contains all human knowledge, making sure that most developers want to use it is pretty important. So, I started building a library called LDO, and this is the story of how it works. Our goal is to build a library that lets you read and manipulate Solid the same way you read and manipulate JSON. You know, to get a person's name, all you have to do is call person.name. To get a list of their friends, you would say person.friends, and person.spouse.spouse would equal person because it just looped back on itself. That seems pretty simple, but to understand how this isn't trivial, I need to first teach you about linked data. You see, if Solid's goal is to be a global database that contains everything, then it better use a data structure that can model everything. Lucky for us, computer science has just the data structure, the graph. No, not that graph, this graph. Nodes connected by edges showing the relationship between two items. And just through relationships, you can create data to represent pretty much anything, like an e-commerce transaction, online reviews, and the main example that we'll use in this video, a person's profile. One of the cool things about linked data is that everything in the graph, like the nodes and the edges, are a URL. This is how Solid is a decentralized database. If I have data hosted on one server, it can point to a URL on a completely different server owned by a completely different person. So while technically this data is in two separate machines, they are abstractly in the same database because they're linked. Linked data is represented by a special coding language called RDF. That stands for Resource Description Framework, but you don't need to remember what that stands for. It won't be on the test or anything. RDF is made out of triples. They're called triples because they contain three things: the subject, the predicate, and the object. For example, this triple says Jackson knows K-drama superstar and major hunk Shin Sun-rok. Whether or not this is actually true is irrelevant. The main point is that the subject is Jackson, the predicate is knows, and the object is Sun-rok. When you start grouping a bunch of triples together, we can start building out a complete graph. But looking at this probably gives you a headache, so how do we make RDF look more like JSON? Turns out there's a serialization for JSON called JSON-LD, and it lets you translate any serialization of RDF to JSON. So that was easy. Video over. Okay, well, it's not actually that simple. Don't get me wrong, JSON-LD is amazing, and it's the basis for the library I made, but it's not as easy as it may seem. If we just translate our RDF profile to JSON-LD, we get... well, that's a lot of URLs. Instead of this with all the URL fields, you probably actually want it to look like this, a lot more approachable, right? The reason it doesn't is because there's no way for the JSON-LD converter to know that this URL should translate to a field called name. If you define a context, you can translate other serializations of RDF into the JSON of your dreams. But that's a big if. Remember, our goal is to build a library to help the typical JavaScript developer. The same kind of person who downloads the isOdd library off NPM when you could do the exact same thing with just 4 characters. No, we need to write a library for the common man. Writing the JSON-LD context requires you to know the URLs of predicates, and no one wants to look that up. We just want to have JSON that matches our mental model of data without doing any work. There's nothing lazier than letting TypeScript tell you how you should write your own code. But hey, this is computer science, one of the few fields where being lazy is actually a good thing. So, the ultimate RDF developer experience is one where you can use it like it's JSON, and you can use it with TypeScript. That way, the developer will know what fields are strings and arrays and so on. So easy! But if that's the goal, then not only does a developer need to define a JSON LD context, but they also need to define TypeScript typings. That's not very lazy, that's the opposite of lazy, that's work. Unless there was a way to combine the process. Let's talk about shapes! In the linked data world, shape languages let you define a schema for RDF. For our purposes, we'll be using Shex as our shape language of choice. There's another popular shape language called Shackle, and for all you Shackle fans out there, I'd love to make my library work with Shackle as well, just need the right funding for that. Anyway, Shex is pretty easy to understand. You pretty much define each field with a type name and define the object that goes with it, all while using question marks and stars to say if 0, 1, or many instances are allowed. Once developers define a Shex shape, I built a converter to convert them into JSON LD context and TypeScript typings. But Jackson, I hear you say, didn't you just say that the average developer doesn't want to define things like JSON LD context? Isn't asking them to define a Shex shape even more work for them because they need to learn how to write Shex? Yes, that may be true, but I'd argue two things. Firstly, using shapes is better because you can generate context and typings from one thing. And secondly, in the future, I don't think that the average developer will make shapes themselves. Linked data dweebs like me will make shapes and share them with everyone else. That way, average developers don't need to worry about shapes or linked data, and all the apps that use the same data shapes can work together because they use the same data structure. I even made a little website that lists a bunch of shapes that are already in use at shaperepo.com. So, now we've got a JSON representation of RDF and TypeScript typings. That's it, right? The primary way to update data in Solid is by submitting a list of what changed. For example, if I changed my name on the profile, I would tell a Solid server that I deleted the previous name and added the next name. But if we modify just a raw JSON LD object, how do we tell that it's been modified? Does the developer need to keep track of that themselves? You're telling me that they need to do work? Well, no they don't, because of the addition of something I call JSON LD dataset proxy. Did you know that JavaScript has something called proxies? They let you intercept and redefine fundamental operations for that object. That means that you can hijack the equals operation or any other fundamental operation and trigger a method that keeps track of the change. So now let's put everything together into a library I call Linked Data Objects, or LDO for short. First, we'll start out with a clean TypeScript library. Next, we can run the command npx LDO CLI init. This will initialize the project with all the proper files. Third, we'll remove the example Shex file and create a new Shex file for our profile. Then we run npm build LDO, and that will run the converter. That gives us a few files like the JSON LD context and the typings, but the most important file is the LDO factory. If we import this factory into our project, we can convert any RDF representation, like the one that comes from querying a Solid server, into a linked data object. From there, we can treat everything as if it's regular JSON. We can read data and make any modifications we want. When we're done, we just need to call the toSparkleUpdate method to convert our changes into a format that a Solid server expects. Now, is this the easiest thing in existence? Well, no, but it's a lot better than what we had before. Solid is an evolving ecosystem, and I'm going to keep working to make sure that it's approachable for the average developer. Hey, thanks for watching that. If you made it this far, then you must really like Solid, or you fell asleep during the video. But either way, subscribing is probably good for you, at least it'll help with your insomnia. This video is sponsored by me. If you want consulting services for Solid, then go to o.team, and we can figure out what works best for you and your organization. And let's work together to make Solid successful. Thanks so much for watching, and have a great time.